Hello, Muleys! I'm thrilled to finally be here on YouTube. This is my very first video on the channel, and I really hope you enjoy it. I've noticed a lot of interest around Maven, so I decided to kick things off with an introduction and explanation. And in today's video, we are unlocking the power of Maven as an essential tool for MuleSoft developers. So let's get started. In this video, I'm going to cover what Maven is and why it's such a crucial tool for MuleSoft developers. We'll dive into the main Maven file, the POM file, explore different types of POM files like the Super POM and BOM. Also, I'm going to talk about the Maven settings file, which acts as a key configuration file. And of course, we'll break down the Maven build lifecycle so you can understand how each phase fits into your development workflow. Let's start with a cool fact. Maven is actually a Yiddish word that means to understand or to comprehend. And in the IT world, that's exactly what Maven helps you do. It's a powerful tool for building and managing Java-based projects, including Mule APIs. I like to think of Maven as a chef. It organizes all your ingredients, your libraries, dependencies, configurations, perfectly. It lays everything out for you so you can focus on what matters. But just like in the kitchen, you still have to figure out how to cook the code and bring everything together. In the world of MuleSoft, Maven plays a key role in making sure your projects are organized, efficient, and easy to maintain. Now, let's talk about how Maven works seamlessly with MuleSoft. One of the key benefits is automated project configuration. If you are using Anypoint Studio 7 or later, your projects are automatically configured with Maven, making it easy to run them either from the command line or directly from the studio itself. And if you already have Maven projects, you can simply import them into Anypoint Studio without any hassle. Next is efficient dependency management. Anypoint Exchange, where you get your connectors and other assets, provides all the Maven dependency information you need. When you select a connector, there is an option called Dependency Snippets, which gives you the exact code to add to your pom.xml file. Lastly, Maven also integrates smoothly with your MuleSoft API build lifecycle. By using the Mule Maven plugin, you can automate packaging, testing, and even deploying your Mule applications. This makes the entire development process much more efficient and manageable, especially when dealing with complex enterprise projects. Now, we've arrived at the pom.xml, the project object model file. This file is an XML representation of your Maven project and is always located at the root level of your project directory. It's the central hub of information for Maven. In fact, as stated by Apache, in the Maven world, a project does not even need to contain any code at all, just the pom.xml. Everything Maven does, whether it's managing dependencies, plugins, or the build process, starts here with the POM file. Let's take a closer look at how it works. First key element we have within the POM file is GAV, which stands for Group ID, Artifact ID, and Version. These three fields work like a unique identifier for your project. The Group ID represents the organization or company that created the project. The Artifact ID is the project's name, and the Version indicates the version of the project. These values help Maven locate and manage the project, ensuring that every project has a unique address within the Maven ecosystem. Next up is packaging. This is especially important for Mule projects. If not specified, Maven defaults to jar. But for MuleSoft projects, you'll often see Mule application, Mule domain, or Mule policy values. When creating a Mule project, it's automatically set like this: packaging, Mule application. It defines the type of project and the associated lifecycle stages. Then we have properties, which are placeholders for values used throughout the POM file. You can refer to these values using $sign together with curly braces. This allows for flexibility when defining project-wide values like the runtime version. Or, as in our example, on the 18th line, we define Mule Maven plugin version, and we get the value of it on the 31st line. by using $sign together with curly braces and the name of the property. The build section. It contains your project's build configuration, including plugins and output directories. Plugins are also an essential part of the build process. For Mule projects, the Mule Maven plugin is a key as it helps package and deploy Mule applications. You can automate deployments to environments like Cloud Hub or Anypoint Runtime Fabric with it. The dependencies section lists the libraries your project needs. Maven automatically downloads these and stores them locally on your machine, usually in the M2 directory. This ensures that all required libraries are available for your project. Repositories. This section tells Maven where to find dependencies that are not available locally. For example, MuleSoft projects often point to Anypoint Exchange. Likewise, plugin repositories specify where Maven should look for plugins. Finally, distribution management. It handles how the project's artifacts, like jar files, are distributed. You can automate the upload of these artifacts to remote repositories such as Nexus, JFrog, or MuleSoft's Anypoint platform. To summarize, POM is a central all-in-one configuration file for managing and building your Maven projects. POM and Maven captures the who, what, and where of your project. Who defines the project with group ID, artifact ID, version, and packaging. What specifies the project's dependencies, plugins, and build configurations. Where indicates where the project's artifacts will be distributed, including repositories and distribution settings. As we already understand and know what a POM is, let's now discuss its types and how they help in managing your projects more efficiently. Let's start from the parent POM. The parent POM centralizes common settings like plugins, build configurations, and properties for multiple child projects. By using a parent POM, you allow child projects to inherit these configurations, making it easier to maintain consistency and avoid repetitive setups. To use it, simply add a parent tag in the child project's POM. Now, let's talk about the master BOM. Bill of materials. It's designed to manage dependency versions in one central location. Instead of defining versions in each project, the BOM keeps them aligned. What's more, you can add the BOM as a parent to the parent POM, ensuring that all child projects inherit both the configurations and consistent dependency versions. This helps your builds run smoothly and avoid conflicts. Now that we've covered the parent POM and master BOM, let's move on to another key file in Maven, the settings.xml file. This file plays a vital role in managing global configurations across all your Maven projects, and you'll typically find it in the M2 directory in your user home folder, where the parent POM and BOM help you manage project-specific configurations. The settings.xml file controls the environment and global settings of all Maven builds. Let's break down its main components. First is servers. This section is crucial for storing authentication details like credentials for remote repositories. For example, if you're working with connected apps or a MuleSoft Enterprise Nexus repository, you can define your credentials in the settings.xml file, so they're available to all projects without needing to include them in every POM file. Then we have proxies, which come in handy when you're working behind a corporate firewall. The settings.xml file allows you to set up proxy configurations, ensuring Maven can access the internet to download dependencies. Next is mirrors. Mirrors give you flexibility by allowing Maven to use alternative repositories instead of the default ones. This is particularly useful when optimizing for speed or accessibility, like using a closer mirror to resolve dependencies more quickly. Lastly, profiles. Profiles are super handy when you need to customize your build setting for different environments like development, staging, or production. You can activate these profiles on demand by specifying them at runtime. As you can see, this file helps centralize important configurations. Servers store credentials for accessing external repositories. Proxies ensure connectivity behind corporate firewalls. Mirrors let you use alternative repositories, and profiles offer a way to customize repository settings globally. Together with the parent POM and master BOM, The settings.xml file helps you manage global and environmental settings, making your Maven builds more efficient and easier to maintain. Finally, let's talk about one of the core concepts in Maven, the build lifecycle. The build lifecycle is a series of defined stages that every project must progress through, ensuring a structured and reliable build process. For MuleSoft APIs, the build lifecycle follows these phases. Validate. First, Maven ensures that the project is correct and that all the necessary information is available. Next, compile. The project source code is compiled. After compilation, tests are run using the MUnit testing framework. These tests don't require packaging or deployment, focusing only on the compiled source code. Next is package. Once the tests pass, the code is packaged into a distributable format like a jar file. Verify. Here, integration tests are checked to ensure the quality criteria are met. Install. The package is installed into your local Maven repository, making it available as a dependency for other local projects. And finally, deploy. The package is deployed to a remote repository, making it available for other developers and projects to use. Each of these phases is executed in sequence, guaranteeing that each step of the process is completed properly before moving on to the next step. This structured approach makes the build process for MuleSoft APIs smooth and reliable. The Maven build lifecycle is a lot like doing laundry. First, you validate that you've got all the dirty clothes. Then, you compile them by tossing everything into the washing machine. You test the process by checking if any colors are bleeding. Fingers crossed. Once that's done, you package them by throwing everything into the dryer. Of course, you'll verify that nothing shrunk or turned a funny color. Afterward, you install the clothes into the closet, and finally, you deploy them by wearing them. Just hope there is no build failure, like missing socks. I hope this video was helpful. Remember, Maven loves saying build failure, but once you know where to check and how to fix it, build success will come much easier. Hopefully, after this video, you'll be seeing it more often. Feel free to leave your thoughts in the comments. I'd love to hear from you. Thank you for watching and see you next time.